Good day everyone, thank you for joining us. I hope you guys are eager to learn more about how Inventor and Advanced Steel works with plant as we discuss it throughout this webinar. Before we get started, I would like to introduce myself. My name is Jolene and I am an application engineer with Modern OneSolve and I will be your presenter for this webinar. Let's have a look at the agenda for this webinar. So we'll start with the challenges that the design team faces within plant projects. We're going to look at the plant 3D workflow. Then we'll have two demonstrations on how plant 3D works with Advanced Steel and how plant 3D works with Inventor. Then lastly, we'll have a discussion and Q&A at the end of the webinar. So if you guys have any questions during the webinar or at the end, please pop them in the Q&A section. And then for any thoughts or comments, you can drop that in the chat section. The plant design journey is filled with many challenges and obstacles to overcome. We are going to focus more on the collaboration between the mechanical, structural, and piping disciplines within a plant design project. So one of the biggest challenges for plant designers is the lack of visibility in their designs. And the design process used to be linear, with designers creating drawings in a single CAD application. This meant that if someone wanted to review a drawing or make changes, they would have to wait until it was complete before they could see how their changes affected other parts of the design. So the result was an inefficient workflow with multiple people working on different parts of the same drawing at different times and having no way of communicating with each other until everything was complete. So then we have file compatibility across solutions and inefficient workflows involving multiple softwares that go together. So there are many different plant design software solutions on the market, but they all have their own data formats and file types. And when you work with multiple solutions to complete your project, you may need to convert files from one format to another, and it can be a very time-consuming and frustrating process for users trying to get their job done efficiently. So even though there are many benefits associated with using multiple software applications, it also comes with its challenges, and one of these challenges include inefficient workflows between the different softwares. So it means that sometimes one person will use one application and another person will use another one for their designs, and these platforms aren't interchangeable with each other. So it might not always be avoidable to use only one platform to achieve your goal, but integration between the platforms can be streamlined and converting the files can be kept to a minimum. So then there's also your plant project that doesn't just have one discipline or one team working on it. There are multiple processes of the project that need to happen in parallel with others in order to meet your deadlines. So for example, you might need to wait for your structural team to finish their models before the piping team can start with their section of the project. And clash detection between teams become frustrating to identify and correct, and this makes collaboration between your different disciplines and teams more difficult. So this is what a typical workflow will look like within the Plant 3D software. You will start by creating your project, doing all your project setups, doing the settings. Once that is done to your company standards, you can start by creating your PFDs, your PNIDs. Once that's finished, you can go over to the 3D modeling, and from your 3D modeling, you can create your orthographic drawings and publish your ISO drawings. So in the background, there's other workflows that also take place, which is your spec and catalogs. So Plant has its own specs and catalog builder where you can create and customize your specs and catalogs to use within your 3D project. Then there's data management happening throughout the project within the software itself or through Vault or a cloud data management. And then you also have your cloud collaboration, which is on the Autodesk Construction Cloud platform, where you can also collaborate and do data management through the cloud. On this slide, we are looking at the workflow on the 3D model side of the software. So on the 3D environment of Plant 3D, you will start by setting up your folders and all your subfolders, breaking the plant into as many sections and areas as you can. Then you'll start by creating your structures. So you can either start creating structures, the general size and shape of your structure within Plant itself, and export that to Advanced Steel to create your steel connections and connection designs, your fabrication drawings. Another way to do this is you can start by creating your structure in Advanced Steel and then import and utilize it within your Plant project. So it works both ways. Then on the creating equipment side, you can create your equipment in the Inventor software. So if you manufacture your own equipment or you have own custom designs and shapes of equipment, you can do that within Inventor and then import it into your Plant project and use it there. So after placing your structures and your equipment, you can start by routing your pipe using the AutoCAD Plant 3D software. And once all of these elements have been placed, you can create and combine this all into a master model. So now we can go over and start our demonstration between Advanced Steel and Plant 3D. Right, here we are in a Plant project and I have a structures drawing open. I'm going to export the structure to Advanced Steel. So I've created an Advanced Steel Models folder within my Plant folder project. And I'm just going to save that exported file in there. So you'll select all your objects and then export that. Yeah, so once the exporting is finished, we can go and import that file into Advanced Steel. So I'm just going to open a new drawing and then I can import that file. So once it's imported into the Advanced Steel software, the model takes on the intelligence of that software. So just take a look at what it would look like. And then you can save this in your Advanced Steel format. So I'm saving it under my Plant project for this webinar in the Advanced Steels folder. So I'm just saving it within that folder so I know where to go find it in order to copy it to my Plant project. So you can say completed if you've done all your connections. In this case we didn't do that, so I'm just going to take that out and save it like that. So now I can close the Advanced Steel drawing and then go back to Plant. There I got an Advanced Steel folder created for myself under the 3D models, and I can copy that Advanced Steel drawing to my project. So there we have our Advanced Steel model. So if you don't want a copy of the drawing, which would be the original one in the Advanced Steel Models folder, so there we got the Advanced Steel model and the exported folder. And in your 3D folders, you have the drawing that we copied to the project. So if you no longer need the Advanced Steel model, you can just go and delete it, but it will still be part of your Plant project as we copied it to there. Alright, then we'll go back to Advanced Steel and we are able to open that drawing from the Plant project folder in Advanced Steel and make edits and changes to the model. So I'll first need to save and close the drawing in Plant. We'll close it there and then go and open it in Advanced Steel. So now we got that Advanced Steel model open in the Advanced Steel software, and you can go and start putting in your connections. So I'm just going to do some basic connections between columns and beams, and I'm just going to use the default connection design that it gives me there. With Advanced Steel, you can go and design your own connection and save it to the Advanced Steel connection library. So we got one in there as well. So there we got our end plates, the bolts, and the cutbacks on the beams done automatically. Let's put in a base plate. So for this base plate, I'm just going to change the anchor bolts. Just to give you a feel of how the connection design dialog box works. Then we can change the length of the bolts. And there we have our base plate. Right, so if you're happy with the changes you made in your Advanced Steel model, you can save this. And then we can go back to Plant. So there's the Advanced Steel model, and there's the changes that has been automatically populated. Now that we have our Advanced Steel model copied to our project, we can now open the piping drawing and replace the plant structure drawing with the Advanced Steel one. Right, so here's the plant drawing that's placed in as an XREF. So I'm going to detach this plant drawing. You can delete it from your project. So there I've detached the plant structure, and I'm going to attach the new Advanced Steel one in its place. So just make sure it's the Advanced Steel one within your project folder, in the 3D models folder. So there I'll find my steel drawing, and I can place it in as an XREF. So there we got the Advanced Steel structure in the place of the plant one, and it also represents and shows the connections made. So you can always go back to the Advanced Steel drawing through your plant project if you want to change the railings, change member sizes, any edits that you need to make on your structure. You can do it through Advanced Steel, and it will automatically populate to your plant project. So here we are in Inventor, and I have a double stage pump that's been designed in the software. So I'll start by adding the connection points that I'm going to route pipe from in Plant. So I'm going to select this surface and then specify the connection type would be a flange. And then I can specify the second point and also change the connection type to be flanged. So once I've got this done, I can now export my pump. So I've created an Inventor folder within my plant project, so I know where to find it. So once the export is finished, we can now go to plant and import it there. So I'm first going to create a new drawing where I can test my equipment after importing it. Okay, so here we got a clean drawing, and I can use my import Inventor component button there. Select that export file, and then we can place the pump. So place your pump, select your rotation, and then you need to specify what type of equipment it is. Okay, so we're going to select pump. And this is what our pump looks like. Okay, so I'm going to have a look at the properties just to make sure the nozzles are in the same pressure class as our project. So there we see pressure class 300. So now my next step would be to change the diameters of the flanges. So I'll select the diameter and select what flange I want to use. That one is supposed to be a 10 inch, so let's change that. 10 inch, select the flange. Right, and then I can go and specify the second one. So that would be a 8 inch. Select your flange you want to use, and there you got the diameter selected, and you can route your pipe from your pump. And now you can utilize this pump within your project. I'm just going to delete these segments. So now you can save this pump to your equipment template. So in your plant project you have the equipment template folder where you can save all equipment templates. So this is the basic shape of that piece of equipment. So we can say double stage pump, and we can save that template in the equipment template folder, and you can use this in future. So there we see, if you select create equipment under templates, there's our pump that we saved, and then you can place that pump again. There's the pump, select the rotation. And now you can also assign a tag to it. So I'm just going to change the tag type there. So there we got P for pumps, but you can change it. So we'll say double stage pipe there, and then you can apply that and assign a tag to your pump. So there's not taken on the DSP abbreviation yet. So I'll select the piece of equipment, go to assign tag, so that it's taken it. You can specify the number, and there it's taken on that new type. So they will see it says DSP 001. So there we got our pump imported from Inventor, from an Inventor model. Right, so that was the webinar. Thank you guys. I really hope you found it informative and how Advanced Steel and Inventor works well with Blanc 3D. We will go into the questions now. So if you guys have any questions, please drop that in the Q&A section. Any thoughts or comments you would like to share with us, please drop that in the chat section. And if you would like to use your mic, just raise your hand and then I can unmute you. So if there are no further questions, then I would like to conclude this webinar. Thank you guys for taking the time to join in with us. If you have any other questions later on, you can contact us on these details on screen, and we are looking forward to hearing from you.